Welcome to another online video lesson. Today's lesson we're going to be dealing with everything we've learned in chapter 9 so far, and we're going to put it on the coordinate grid or the coordinate plane. In lesson 9.5, it's titled Polygons on the Coordinate Plane. For the table of contents, I'm on page 94. You just have to trim down the green note sheet that you got in class and title it Polygons on the Coordinate Plane. Before we try some examples of putting shapes on the coordinate plane, there are a couple of tips that I want you to fill in to help us with this skill. The first thing is that we are going to see just a list of points. And if ever you see coordinate points referring to a shape of any kind, you need to create a visual. You need to graph those points. So you have to graph the picture in order to work with the picture most efficiently. You're going to today see questions about the perimeter and the area. So you have to make sure you're keeping straight which one is which. So perimeter is going to be referring to the outside edge or the fence around the shape, versus the area is the number of square units that will fill the inside of the shape. Another tip, we are going to be finding distance between 2 points to find the length of the sides. So just a reminder, to find the distance, we're going to be subtracting the coordinates that are different. Today, our shapes are all in the same quadrant, so we don't have to worry about adding the coordinates that are different. So this is the tip for today. Finally, when you see the word classify, what does that mean? That means actually just name the kind of shape that it is. If it's a triangle, you can be more specific. What kind of triangle? Right, scalene, isosceles, equilateral. If it's a rhombus or trapezoid or parallelogram, those are the kinds of classifications that we're going to need to do today. So here's the first example. Very simply put, we have a list of points. A shape has vertices A, B, C, and D, and those coordinate points are going to form the shape that we're going to work with. Those are going to be the vertex points that will form the shape. Use the coordinates to find the length of each side. We're going to be dealing with line segments today, and then find the perimeter and classify it. I'm going to do some work on the side of my grid. I know I put yours over on the right-hand side. There's a little bit of space in between the problems where you can do some subtraction. First thing first, though, we have to graph our picture. So when we graph, remember, over to the right and then up for the X and the Y. And this is going to be labeled A. If you don't have letters, it's kind of a good idea to just create your own, but we have A, B, C, and D. So the second point is 7. We're going to go over 7, up 8, and label it B. 7 over 7, up only 5, or C, and then our final point is D. Whenever we're on the coordinate grid, it's a good idea to use a straight edge to make that shape. So go ahead and connect the dots. And again, the points, the coordinate points form those corners of your shape, and it's really important to be able to see the shape so that you know what line segments to talk about. Now we have to tell the length of each side. Because this is a rectangle, we can go ahead and classify that now. I'm just going to write it on the bottom of this grid. We have that part done. Because it's a rectangle, I know that the ends are the same length and the top and bottom are the same length. So really, when I'm finding side lengths, I only have to figure out 2 of the sides, and then I can just name the others that are the same. So when I'm finding the length of a side, I'm going from point A to point B to find this length. When I write a line segment, I have to use the 2 letters that are on each end, and then I'm going to draw a line above the A and B. That's how we write a line segment. So line segment AB, it starts at 2 and then it ends at 7. So we can just subtract 7 minus 2, which equals 5 units. So now we can also name the bottom of the rectangle, that's line segment DC, as the 5 units as well. Now let's do the left-hand side of the rectangle, and that is AD. So we're going to label AD, and then we're going to figure out what two numbers to subtract. Notice the difference in the coordinate points are 8 and 5. We're going to subtract 8 and 5 and get 3 for our length. Yes, we can just count 1, 2, 3, but I'm also showing you how to subtract as well. Because this is 3 units, that means the opposite side is also 3 units, so that is line segment BC is 3 units. To find the perimeter, we're going to add up all of the sides. Because we found AD to be 3 units and AB to be 5 units, you have a choice of doing 3 plus 3 plus 5 plus 5, or I'm going to just double the 5. So perimeter equals 2 5s plus the 2 3 line segments lengths. This is 10, this is 6, so we have our perimeter of 16. We always need a unit. Because this is on a grid and we don't have an additional unit, we're just going to label it units. It's not squared because it's perimeter. This one is exactly like the other one, so I want you to try it on your own first and then resume to check to see and make sure you got it right. So ABCD has vertices A, B, C, and D, and we're going to use the coordinates to find the length of each side again. You have to do all 4 sides, and then find the perimeter and classify the shape. Go ahead and give it a try. So the second example, you should have graphed 2, 1, 4, 1, 2, 5, and 4, 5, and labeled them A, B, C, and D. It is a rectangle. And then over here, I found the length of each of the 4 line segments that make up the rectangle shape. AB, I subtracted 5 minus 1, which is the same as CD. Then I did the same subtraction for BC. I'm subtracting 4 and 2 to get 2 units, so AC is also 2 units. Again, I chose to double the 4 and double the 2 when I was finding the perimeter, which equals 12 units. Hopefully that's what you got. We'll do the third one, which is a little bit different. So for the third question, we are given coordinates and vertices of a garden, and there's no letters, so we can create our own if we'd like. And then it tells us if each unit represents 12 inches. So we're going to do something after we graph and figure out the perimeter to figure it out in inches, not units. And then find the perimeter in inches is what the directions say. So the first vertex that we have to plot is 0, 1. So that's going to be here. I'm just going, for the sake of making it easier to refer to, label it A. The second point was 0, 4. So I'm going to call that one B. The third was 8, 4. And then we have 8, 1. So that's going to be my C and my D. You can see it's going to be another rectangle. We are dealing with the perimeter, so we have to find the lengths of these sides after we connect the dots. So we have similar line segments because of the rectangle. So BC is going to be that long one. It starts at 0, ends at 8. So 8 minus 0 will be our length in units. And that's going to be the same as AD. We need all of the units so that we can find the perimeter. It's not asking us to list them all out, but we still have to find them. So here's 8 units and 8. Now let's do the ends. AB is going to go from 1 to 4, so that is a difference of 3 units, which is the same as CD. So that would be 3 and 3. Now all of these numbers are in units. Let's find the perimeter in units and then we'll convert to inches. So the perimeter is going to be 2 times 8 plus 2 times 3. That's going to be 16 and 6, which is 22 units in length. Now, the problem that I read had this little disclaimer saying that each one of these boxes actually represents 12 inches. So you have 22 units or 22 boxes, but now we have to multiply each box by 12 to find the length of the perimeter in inches. So our last step is to take our 22 and multiply it by 12 to get our perimeter in inches. When we multiply, it's going to be 264, and now we can say our inches as our unit. Now our last example deals with something that we're really gonna talk more about in our next video. However, here's a little preview. When you have 2 or more shapes that you can kind of fit together like a puzzle and make a different kind of shape, it's called a composite figure. 2 or more shapes in one figure. So I can draw lines in different parts of the shape and make smaller shapes. We kind of talked about that when we talked about decomposing for our trapezoids, making a trapezoid into 2 triangles and a rectangle, much like this arrow. And then this ends up being a trapezoid and a triangle, if I can make a straight line there. So we're going to deal with this again next video. We're going to talk just about composite figures, but our last example on here deals with a composite figure that's on the coordinate grid. We have a composite figure that's already divided for us, so a lot of the hard stuff is taken care of, and we have to find the area of this shape. So we haven't done an area 1. We have to use our formulas for these 2 shapes. Let's deal with the rectangle first. The rectangle formula is a little bit easier. It's just the length times the width. So we have to take these vertices and figure out the distance so that we can find the length of this rectangle. So 1, 2, 3, 4, 5. Since we don't have a coordinate grid to refer to, we can't subtract. We're just going to literally find the spaces. And notice I started counting when I started moving. You don't count the actual lines, you count the spaces. So this length is going to be 5 units. And then the width is going to be 2 units. Now we're going to plop that in. 5 and 2. The area is 10 units squared. That's the bottom part of the shape. Now we have to tackle that trapezoid. Great review. We need more work with trapezoids anyway. We need the 2 bases. This is base 1, and here is the length. And so base 1 is going to be 3 units. This dashed line represents the second base of our trapezoid, B2, and we're going to figure out that that is 4 units. Finally, the right angle happens at these 2 corners. So this side of our trapezoid is our height, which is 2 units. Once we've figured out those numbers, we can come over and use our trapezoid formula. We're going to find the area by taking half of the height and multiply it by the sum of the 2 bases. Now let's pluck and plop. We have 1/2. The height is 2, and then our bases are 3 and 4. This I love right here. 1/2 of 2 just goes away because 2 divided by 2 is 1, and we have the area of 7 because all we have to do is add these 2 up, and we have 7 units squared. So if the top is 7 units squared and the bottom is 10 units squared, to find the total area of the shape, we have to combine those 2 areas, 10 plus 7, or 17 total units squared. So we're going to work with the coordinate plane in class more to practice area and perimeter. I look forward to doing that with you, and I hope